I hope you had a chance to try out the XMT350. That's one of the things it can do is it can output DMX. It can also do other things as well, which you'll see later on. There are lots of these handheld testers, and they vary in. There's different features and price ranges. You know, the two that I carry around all the time. I have an XMT350. I also carry around a pocket console, which is a battery-operated 8-fader single universe console. It's just a very basic way of testing the system. You know, I can do a rig check. So what I like to do is I will, when I'm putting in a system, we'll load it in, we'll float the truss waist high, hang the fixtures, run power, run data. Now, to test it out, to make sure that they're all powered up right and the data cables work, I'll just take the home run, plug it into the pocket console, and I patch all 512 channels to one fader. And just by raising that one fader, the lights will come on and do something, typically like in a big white light. And so that way you can verify that you've got good power and good data. And so now you can fly the rig, and you know that you won't have to climb up the ladder or you know, fly the rig back in to fix a power issue or a data cable issue. So now, but of course it doesn't do all the other things that the XMT does, like RDM and that kind of stuff, which we'll talk about later on. But you know, if you there's all kinds of things, like this is the pocket console right here. This is the XMT. Somebody asked me what's the difference between the XMT 120 and the XMT 350. The 120 is for DMX only. The 350 is for DMX and RDM. Of course, the 350 costs more than the 120, but it's got a lot more features, and you'll like RDM. If you're not familiar with RDM already, you'll enjoy it. Doug Fleener makes a gizmo. Bob Goddard makes a little DMXter. There's others. There's Chauvet makes one. Blizzard makes one. And of course the Acclaim one, which is really the XMT 350. So the advantage to these is that in addition to just outputting DMX, you can also receive DMX, and you can check the timing and other features or other aspects of your DMX. So Doug Fleener makes the Apathy, you know, which is it's a single channel control. It's just a very simple kind of device. It's kind of, I don't know if it's what's the opposite of apathy? What, you know, like you don't need a great big console to test out your system. A one channel thing will work, right? But they also make line testers as well. A line tester is just an XLR connector with an LED soldered between pins 2 and 3. Now, it's not the world's greatest DMX tester, but if you plug it into the output of a fixture and it lights up, then you know at least you've got some activity on the line. So it's just a quick and dirty way of testing to see if you have anything happening. Okay? Now, this is a microphone cable tester. All right? And this is what I was talking about. This one might have actually high impedance, low impedance, maybe? I don't see it on here. But anyway, the point is that this is a great continuity tester. And you know what? The XMT has a continuity tester as well. It'll tell you if pin 1 is wired to pin 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5. But that doesn't tell you anything about the quality of the signal. And that's what this is, just a continuity tester. So if you wanted to test your cable to find out, did I wire pin 1 to 1, 2 to 2, 3 to 3, go for it. This works fine. But if you confirm that it's wired correctly, that's no guarantee that it's actually a functioning DMX cable. That's the whole point, okay? So, now, other things you can do with the XMT, you could, for example, test your output from the console because it receives DMX. And you know, troubleshooting is all about pinpointing the problem. You want to narrow it down and pinpoint the problem. Because you start off, it could be anything. So you start eliminating things. And you start eliminating possibilities. And the more you can eliminate, the more you narrow it down, the more you pinpoint the problem, the easier it's going to be to resolve. And since the console is usually the easiest to access, you might want to start there. Is the console configured properly? Is it outputting DMX? So what you can do is you can take your handheld, and if you put it in receive mode, you go plug it right into the console, and you turn on the console, and you see if it is receiving any DMX values. And in receive mode, it'll tell you what the values are for each of the channels. So right away, you can eliminate one thing right off the bat. You can also check the timing and refresh rates. So DMX has very specific timing. So the way it works is the console is generating values for every control channel, 512 per universe. So every port, there's 512 8-bit values. DMX is an 8-bit protocol. Now with 8 bits, there are 256 different steps. So there's 256 different combinations of zeros and ones when you have 8 bits. And so what it does is it will generate values for all 512 channels, and it puts those in a packet. So it's a virtual packet. It's not, you know, it's not a hard packet, but a virtual packet, and it sends that packet out over the network, over the DMX network. And then it checks the values again. It checks all the faders, all the settings on the console to see if any of those values have changed. And then whether they've changed or not, it will refresh those values by sending another packet of all 512 values. But in between the first packet and the second packet, there's something called a break. And a break is when there's no activity on the line. There's no voltage generated for at least 92 microseconds. Now, a microsecond is a millionth of a second. To you and I, it's imperceptible. But to a computer or a console, it's a perfectly measurable amount of time. You know, and so it's a signal to the receivers saying that this is the start of a new set of values, of a new packet of data. And so after the break comes something called the mark after break. And that's where the voltage goes high for at least 12 microseconds. And that signals that the very next thing that you're going to see is the first byte of data, the first 8-bit value. And that first 8-bit value is for DMX address number 1. And then the next 8-bit value is applied to DMX address number 2. And the next is 3 and 4 and 5, all the way down to 512. So after the console spits out the value, the 8-bit value for channel 512, it starts over with the break, a mark after break, and then it refreshes the data. And it does that over and over and over again. Now the baud rate for DMX is 250,000 bits per second. That never changes. 250,000 bits per second. And honestly, that's very, very slow. It's really, really slow. By today's standards, it's really slow. But think about, you know, DMX came out in 1986. So back then, the computer hardware was much slower than it was today, than it is today. Back then, a very common processor was made by a company called Zilog, and it's called the Z80. The Z80 processor had an operating speed of 3 megahertz, 3 million operations per second. My computer, it works at 3 gigahertz. It's 1,000 times faster. So we're using 1986 technology, basically, or 1986 protocol, so no wonder it's 250,000 bits per second. But you know what? It works. it's plenty enough speed to do what it needs to do, and on top of that, it's stable and reliable, which is why we're still using it. So, but what you can do with the XMT is you can go to the console and plug it in, and you can check the timing. You can check the break time, you can check the mark after break, and you can check the refresh rate. And those are important troubleshooting tools because there are some devices out there that don't strictly adhere to the DMX protocol, and they cause glitches. Then there's others that have slow processors, very inexpensive gear that have slow processors that can't keep up with the data and they glitch. So you want to check to make sure that the timing is correct on the signal going to those fixtures. Make sure, is it the fixture, is it the console, is it the data splitter, is it the data cable? So by using this, you can look at the timing and you can tell if it's within the DMX spec and whether it's supposed to be working properly. The other thing you can do is you can play with refresh rates, because the refresh rate is how many times per second is the data being updated from the console. Now, if you look at the math, the baud rate for DMX is 250,000 bits per second. And every DMX packet has 513 8-bit values. The first one, the very first one, I said is address number 1. There's actually one before that, and it's called the start code. So the very first 8-bit value in a packet is what tells the receiver what kind of data it is. And chances are it's either going to be DMX packet or it's an RDM packet. If it's an RDM packet, that's a signal to the receiver, to the light, saying, hey, this is not DMX. Don't treat it like DMX. If you treat it like DMX, it's going to glitch. And chances are it's going to flicker, because that's what I've seen before, is that if a light treats RDM data like DMX data, you get a faint flicker. So you have to turn off RDM at the console to make that stop. Okay? But that very first 8-bit value is called the start code. And then comes the data for address 1, 2, 3, 4, 5, all the way up to 512, and then it starts over again. Now, every 8-bit value is framed by 1 start bit and 2 stop bits. So really, the packet has 513 values that are 11 bits long, not 8, because they add 3 bits to frame that data. So now, if you say, well, what is 513 8-bit values plus the start and stop bits factored in, and then you factor in the break and the mark after break, what you find out is that with the baud rate of 250,000 bits per second, then the most number of packets per second that can be sent out on a DMX network is 44. So 44 packets per second is the maximum, what we call the refresh rate, because the data is refreshed 44 times per second at the most. Now, it turns out that most lighting consoles default to a slower refresh rate. Why? Because there's a lot of gear out there with slow processors that can't actually keep up with 44 packets per second. So consoles like the Grandma default to 30 packets per second. The Hog defaults to 30 packets per second. And honestly, I don't know what the M series console's default is for the refresh rate, but we can easily find out. So if I were to grab the XMT, and what I'm going to do is I'm going to put it in, see, which mode do I want? So I've got either receive, send, RDM. There's a flicker finder in here, which we'll talk about. There's a tracer, and there's a timings, and there's a cable tester. There's a sequence, so you can build a sequence of DMX commands, and there's fixtures, and there's a PC connection, and then there's options. So, and I don't remember is it timings? Okay, so Red says that I can find the refresh rate in the timing, so if it doesn't work, we're going to blame him, okay, not me. It's his fault. So I'm going to go into timings mode. It said, it says the DMX signal is okay. It says the refresh rate is 37 hertz. Now I assume that's the default. I don't know. Somebody may have changed it. Now typically the refresh rate goes in increments of 5 or 10 or even numbers. I've never seen one before that is specifically 37, but maybe you have more granularity on an M-series console than you do in others. But this says 37 hertz refresh rate. The break length is 207 microseconds. The mark after break is 28 microseconds. And it's receiving all 512 channels, because a console could output less than 512 channels. If, for example, you have a 48-way dimmer rack and 48-way controller, then it will only output 48 values, 48 DMX values, before it starts over with the break and the mark after break.
Do you want to see what it looks like?
Yeah, so if you want to come take a look, here's the output right there. And I see that our lunch is here. So, oh, it's going to take her a few, okay, so never mind, forget that. Yeah, question?
We have a lot of issues with people that are trying to control our units with ETC consoles.
Uh-huh.
And if they have a higher rate or the higher refresh rate, will that cause issues with
yeah.
units?
All right, so I'm sorry, what's your name again?
Zach.
Zach. So Zach said that, and is this at a particular location you're saying, or in general?
We get a good amount of calls from ETC consoles that don't work well with our units.
Okay.
ETC consoles or nodes too.
Okay, so what Zach is saying is that he's noticed a lot of issues where people are using a specific brand of console with his gear, and they have issues. And he's asking if changing the refresh rate would help. And the answer is, I think it would, and I'll tell you why. So I've done some work with the NBA before, because the head production electrician for the NBA is a guy named Rob Baxter. He's a good friend of mine. And so a couple of years ago, the NBA wanted to find out if some of those new LED sports sliders would render colors well on television, because colors to sporting teams is important. They want to make sure that the Chicago Bulls look red on TV and not orange, and that the LA Lakers look blue on TV, purple on TV, sorry. Ooh, sorry. On TV and not red. So what they did is they sent us to a basketball arena in Reno, Nevada, where we set up some LED sports sliders. There were prototype fixtures, and we had 120 of them, and we lit up a basketball court with them, and then they shipped us a crate of NBA jerseys, two for each team, one home, one away jersey. So the idea was we set up the lighting, and they sent out a camera crew, and we held up the jerseys in front of the camera, and they sent the camera feed to the home office in New Jersey, and all the NBA officials sat around the conference table watching the monitor, looking at the colors to judge whether or not they looked right under the new LED sports sliders. But while we were setting them up, there was 4 catwalks over the court. We had 120 fixtures, so 30 lights per run. And so we hung the fixtures, we cabled them up, power and data. We plugged them into the data splitter, ran that to the console, and then we went up to the catwalk and we were dressing the cables. Tying them up, tie wrapping them, getting them out of the way. And in the process of doing that, every once in a while we see this bright flash out of the corner of our eye. And we're like, what's that? And it'd go away. So we'd go back to work, and then maybe 10, 15 minutes later, there'd be another flash on the other side of the court. And so now we have a problem. We've got to resolve this problem. And so the first thing I think of when I see those kinds of issues is data termination. Did we remember to terminate our runs? So I went and checked. There was only 4 runs, and they were all terminated. So that eliminates that problem. So the next issue in my mind is, well, maybe we have a bad data cable. And it's funny the way these work, because sometimes when you have a bad data cable over here, it's that light over there that flickers. It's not always, right next to it, right? So we started changing out cables, and to my recollection, we changed out 120 cables, and we still had the same problem. So that only leaves the data splitter and the console. It's an easy thing to change the data splitter. We still have the same issue. So now we're down to the console. So we're all down there looking at the console, scratching our head. And it's the same brand console that you just mentioned. And
what brand was that?
it was ETC. I'm not afraid of no ghosts. But so now one of the things that these XMTs have in them is a flicker finder, which comes in really handy, because that's what we had. We had a flicker, right? And so the way the flicker finder works is that if you go to the console, you turn it on, and you set some levels of DMX, it's now outputting DMX. And if you don't touch it, you don't change it, then the value should stay the same. So you take your handheld and you put it in flicker finder mode, and you plug it directly into the console, and you put it down, you walk away, and you come back maybe 30 minutes later to see if any of the values have changed from the console. Because if they have, that's the source of the problem. But in this case, it wasn't. It didn't find a flicker. It didn't catch a flicker, right? So now we're out of, we've eliminated everything, right? And I don't remember who thought of it. I think it was Rob that thought of it. Rob said, hey, why don't we change the refresh rate? And we said, well, yeah, that's a great idea. So if you go into the settings on these consoles, there's 4 different settings for the refresh rate. There's fast, medium, slow, and very slow. So we changed it to very slow, and guess what? The flicker went away. And so that's a great tool to have to troubleshoot your system. If you have flicker or flashes or something like that, then try changing the refresh rate, see if that makes a change, and sometimes it will. Now the trade-off is that if you have too slow of a refresh rate, if you're trying to strobe lights in sync with each other, if you have a big system and you have a low refresh rate, then you may see that those lights get out of sync with each other. You may see that they get out of sync. So there's a trade-off between a high refresh rate and a low refresh rate. But it's a great troubleshooting tool to isolate the problem. In this case, the problem turned out to be the firmware for the DMX in the fixtures had a bug in it, had a software bug. And so just by fixing that bug, then ultimately the real problem was the software, the firmware in those fixtures. Okay? So yeah, that's a good troubleshooting tool to have. Okay? Any other questions or comments?
I'll make a comment. A lot of schools, elementary schools in particular on Long Island, are getting like Elation. I'm not sure of the model, but like the strips, multicolored strips, color courses with the manufacturer board. And we end up having to turn off our RDM because we'll get flicker. And if RDM is enabled,
yeah,
we get the flicker as soon as we turn it off.
Yeah, so what Kevin is saying is that for certain fixtures, if the way RDM works, now we're going to talk about RDM in great detail, but the way RDM works is that the RDM allows fixtures to send data back to the console, but they're not supposed to send data back to the console until an RDM command is issued to them asking them to send their information. But some consoles will automatically, behind the scenes, without your knowledge, will send out RDM commands to fixtures looking for data back. Now, in the early days of DMX, there was only one start code, and that meant this was DMX data. And because there's only one start code, some manufacturers chose to ignore it. In other words, they said, why am I going to write code to decipher the start code if there's only one start code? So they didn't put that in. And apparently some fixtures to this day still don't interpret the start code. So now if the console sends an RDM command to that particular fixture that doesn't understand the start code, it's going to treat all data as DMX data, including RDM, and it's going to flicker. And I've seen that before. That happened on the D60s at the Performing Arts Center at Texas State University. And the solution in that case is you turn off RDM on the console, or they also make start code strippers. I know Doug Fleener makes one. I don't know if Elation has one, but it's just a box that will look at the start code, and if it's not a DMX start code, it doesn't pass the data down the line. So that way, if you put all of your RDM fixtures before the start code stripper and all of your fixtures that don't understand RDM downstream, then they will work together and you can still use RDM. Okay? Did somebody else have their hand up? Any other comment? Yes?
I was going to say, as far as troubleshooting, you first want to check that like you said, that issue you had with the MBA, you first want to check that your run is terminated.
Right.
Then if that's terminated, then go to the cables.
Yes.
Then after that, the splitter, then the console. Is that like a specific order? Or
Well, that in this case, that's the order that we did it in because we were already up in the catwalk. So I started at the end rather than from the console. If you happen to be working near the console, then you might want to go the other direction. Okay? But the whole point is you try to narrow down the problem so you can pinpoint it. Okay? Any other questions or comments? Okay, in that case, why don't we go ahead and break for lunch?